Operations on polynomials. What we'll be looking at in this video will be adding, subtracting, and multiplying polynomials. Division, we're going to be doing that separately because it is a lot more complicated. For adding and subtracting, you can basically think of it as combining like terms. When you originally see the problem written, you're going to notice that the two polynomials are going to have parentheses around them. Those parentheses, with the case of addition, really are just going to highlight what you start with and then what you're adding onto it. So we start with this polynomial. We're going to be adding onto it this polynomial. The parentheses really just indicate what is the beginning part and then what you're adding onto it. But when you begin to add these, you're really just going to ignore those parentheses, at least in the case of addition. You're going to ignore them. Okay, and then what we're going to do is look for like terms. And we should start with the highest degree. For example, the 3y cubed is the highest degree that we have here. Okay, and then you're going to look to see if there's anything else that's a cubed, which we don't have. Okay, so we're just going to keep that term. Okay, then squared terms would be the next highest degree, which we have here. We also have here. Okay, and you're going to notice that I circled first, boxed the second. This is one of the strategies I use to help organize and keep track of what I'm doing. Okay, so those two added together is going to give you a negative 6y squared. We then move to the linear terms. We have here and here. Together, that will give you negative 5y. And last, we have a constant, which is easy to identify as the last item because everything else has been circled, boxed, or underlined. And that's it. When it comes to subtraction, it is a lot like addition, except that subtraction symbol that we see in the middle here. You need to think of that as a -1 that you're going to distribute across all of the terms that we have in the second polynomial. Okay, so before we start grouping anything, I would rewrite the whole problem. The first polynomial, you're just going to leave as it is. You got 8x cubed minus x squared minus 5x plus 1. The second, you're going to distribute that negative across to everything. Okay, a lot of arrows in there. The first, you'll always get that right because the negative is right next to the 3. Okay, so you get negative x cubed. But it's the others that you really got to pay attention to because they're going to change their signs. This is going to be a minus 2x squared. This is going to be a plus x. This is going to be a minus 7. Okay, everything's going to change its sign. So as advice, you should just go ahead and rewrite it. It does not take that long, but it shows you what the signs are, and then you don't need to worry about it when you start grouping the terms. Okay, here's your cube terms. Those group together as, as a 5x cubed. The squared terms are going to give you negative 3x squared. The linear terms will give you negative 4x. The constants, which are easy to identify again because I've already circled and boxed and underlined everything else, the constants are going to give you negative 6. With regards to multiplication, what we're going to do is distribute all of the terms that would be in one of the polynomials. That could be this right here, the x plus 3. Usually pick the polynomial with least terms to sit in the front. Okay, and then you're going to distribute both of the terms that are there. That would be the x and the 3. You're going to distribute both of those to all 3 of the terms that we have here. So we're going to begin with just the x. Okay, and that's going to create 3 terms. And as we distribute that x, you're going to notice it's just going to increase the exponent to the x's. You're going to get 3x to the 3rd power. You're going to get negative 2x squared. You're also going to get positive 4x. Okay, that's the first part. The second part is going to be distributing the positive 3. Make sure that you look at that as a positive 3, because if it had said minus 3, that would be a negative 3. But we're going to distribute a positive 3 to each of those terms as well. You're going to get a positive 9x squared, negative 6x, positive 12. Once you do that, you're going to group like terms. Here's your cubed term. So we get 3x cubed. Here are your squared terms. That should be all of them. You get plus 7x squared. Here are your linear. And you got your constant. All right, I also want to include some special products. These are a few cases that if you recognize them when you're multiplying polynomials, you could actually save yourself quite a bit of time. Okay, maybe in some cases just a little bit of time, but anytime you do save is time saved. Okay, the first is the product of conjugates. Conjugates are going to be two binomials that look exactly like each other, except one of them is addition, the other one is subtraction. Okay, we've got a plus b, we got a minus b. Those would be conjugates. When you multiply them together, you're going to get what we call the difference of squares. You're going to get a squared, you got a b squared, so that's the a and the a for the a squared. You got b times b for b squared. You're also going to get a difference, you're going to get subtraction. And that comes from the positive b and the negative b multiplying together. What's important about this is that usually when you multiply binomials, you get a linear term. You get a couple of terms that you would create through multiplying that you would add together as a linear term in the middle. But because we have conjugates, the two terms that we would have created would cancel with each other. If you look below that at the square of a binomial, you're going to notice that we do have a middle term. Okay, so in the difference of squares, that gets eliminated. So if you recognize this, you can easily just write the difference of squares. Okay, so the square of a binomial does not cancel out that middle term. Okay, but the two terms that would be created when you're distributing and doing all your multiplication, they become identical to each other, they become a product of a and b, and you get two of them, so you're going to end up with a coefficient of a 2. You can sometimes refer to this as square double square. Okay, so the cases would be a plus b times a plus b, which could also be written as a plus b squared. Okay, you may see it that way. Likewise, you could have a minus b squared. Okay, which would be a minus b times a minus b, and you would get this, which looks almost identical to the other one, except because we've got subtraction, you do have subtraction here. You do not have subtraction at the end because negative b times negative b, shown here I guess, would give you a positive b squared. And last, the cube of a binomial. A plus b to the third power, a minus b to the third power. Okay, and that will end up taking on that structure. Instead of digging into this and looking at all the distribution, how we get these terms, what I want to do is remind you of the binomial theorem and Pascal's triangle. Okay, in Pascal's triangle, where you start with the 1, got a couple of 1s underneath it. After that, you get 1, 2, 1. And these are the coefficients that we see here. When we square the binomial, you got a coefficient of 1, a 2, and a 1. When you go to a third power, the coefficients will be 1, 3, 3, 1, which is what we see here. We have a 1, we have a 3, and a 1. Okay, as far as the variables, you would just start with your first, you'd have a cubed, which would drop to a squared, then to a, then to no a. At the very end, you're going to have b cubed, and it goes backwards here, b squared, b, no b. As far as the operations, there is a little bit of a difference there. If you have addition, everything is addition. If you have subtraction, every other term is going to be negative. You're going to start positive, go negative, positive, go negative. All right, for example 4, let's go ahead and use those special products. The first that we have here are 2 minus 3x times 2 plus 3x. Those are conjugates. They're conjugates. They look identical to each other, but one of them is addition, the other one is subtraction. That means that you're going to get the difference of squares. You can get the difference of squares here. So 2 squared is going to be 4. It's going to be a subtraction. It's always difference of squares. 3x times 3x is 9x squared. And that's it. Time saved. Okay, for the next, we have a binomial being squared. Okay, 3x plus 4y times 3x plus 4y. So for that, we can use square double square. The first term that we're going to have here is going to be 3x squared. I'll go ahead and expand it a little bit later. Okay, the last term that we're going to have is going to be 4y squared. In the middle, what you're going to get is 2 times the product of these two. It's 2 times AB. Okay, so we're going to have a plus 2, see if I can even get this to squeeze in here, 3x. You're going to get a 4y, let's scoot this over, plus, you got 4y squared. Okay. All in all, it looks like this. You get 9x squared plus, let's see, 2 times 3 is 6, 6 times 4 is 24, x, y. And at the ends, you get plus 16 y squared. All right, and then for the last one, we've got y plus 5 to the third power. Okay, so for that one, thinking back to Pascal's triangle, you're going to have the coefficients 1, 3, 3, and 1. Okay, at the very beginning, you're going to get all y to the third power. Your second term is going to be, let's scoot this over just a little bit. We don't need that much space. Your second term is going to be y squared, so it drops down by 1, times a b. Your next term is going to be 3 times a single y, so those count down, times 5 squared. Your last term is going to be completely 5 to the third power. Okay, your y exponents are going to decrease, and as they decrease, you're going to bring in a 5. So you bring in a 5, you bring in a 5 squared, and then you're completely at 5 cubed. Okay, and then we just clean it up, and that's our answer. Of course, all that is going to be addition because you had an addition here. If it had been subtraction, this would be subtraction, this would be subtraction. Okay, we get y cubed plus, that'll be 15y squared, plus, that would be 25, so 75y, plus 125.
Later, blah.